sometimes, although we can solve it just like the way we did it, but we can do another thing. Let me redraw the same diagram here and see what can be done. So our original loading is like this: triangular or uniformly varying load. What I can do, I can add some fictitious load on top of it. So what I did, I added some fictitious load on top of it, so that this load could be converted into a rectangle, because this load I added myself. So I'll add a similar load in the reverse direction as well. Does this make sense? So our original loading was like this, and I added a fictitious load to convert this load into a rectangle. Once I convert this rectangular load, or because this is load I added myself, I need to balance it out by adding a similar load exactly in the opposite direction. So I have the red arrow is pointing downwards and the blue arrow is pointing upwards. So this becomes an easier problem to solve, because now that problem of having different two kinds of load is gone. Let's quickly see what does that mean, because now this is simple rectangular load with one side W0 and one side L, and this will definitely be equal to W0 here as well, but the only difference is the direction is upward. So again, the two forces F1 would be equal to, one is a triangular load, this rectangular load, that is W0, and although it's L, but when we take a segment, it will become X, and F2 would be equal to, for this load, it would be 1/2 W0 X times, how much is this? We'll do the same thing. This is Y, this is X, and the ratios of the W0 to L must be equal to the ratio of Y to X. So Y would be equal to W0 over L times X. And this will become W0 over 2L X squared. So it's a much easier problem to solve if we just do some little bit this one, because B will be much easier. It's W0 X. It's a negative because this load is acting downward. So minus W0 X. This load is acting upward, the blue one, F2. So this will be plus W0 over 2L X squared. It's much easier. No difficult triangles to solve. And similarly, we can find the bending moment. So sometimes we can play with the load, add some fictitious loads as well, but those have to be balanced out as well. So I just added a triangular load myself to make this even, and then I have to add the other load to make it even. Those things are possible and they're allowed to do it, because we just have seen that doesn't change the overall loading situation. The loading situation, this answer is exactly the same answer as we had previously as well. Sometimes we also take the symmetry as well. If the load is exactly same on both sides of the beam, we just solve half of the beam. So I'm going to solve one more problem like that and see what is the can be done. So the problem next we have on cards is and there's a beam